Week 3 of Introduction to Algebra. This week we will be talking about translating sentences to equations, two-step equations, and we will begin our work with inequalities. In your notebook, you should have copied these phrases onto a page titled Translating Sentences to Equations. When we look at examples such as 12 more than a number is 37, we start by writing 12 more than a number, which would be 12 plus x, equals 37. 6 less than a number is equal to 17. Always be very careful when you see the expression less than. It means we start with the number first minus 6. So this sentence would be x minus 6 equals 17. In example 3, the product means multiply. So the product of 5 and a number is 40, would be 5x equals 40. On our last example on this slide, the quotient of a number and 3 is 5. This means that a number divided by 3 equals 5. In the next set of examples, all of these equations will require two operations. In example number 5, 4 times a number plus 8 is 20, means that we have 4 times x plus 8 equals 20. 4 less than twice a number is the same as 12. Always be cautious when you say less than, because this means we're going to start with 2 times a number, or 2x, minus 4 equals 12. And a number doubled and increased by 5 means that first we'll multiply a number by 2, then add 5, and say that it is equal to 13. These next two examples require the use of parentheses. In example 8, we have half of meaning multiply. The sum of 3 and a number is 4. When we see the sum, we want to think parentheses, because this sentence tells us to find the sum of 3 and a number first, and then multiply by a half. So I would write this as 1/2 in parentheses, 3 plus x equals 4. And in our last example, I have 10 times the sum of a number, and 9 is 100. Again, when I see sum of a number and 9, it tells me that I should add those together first. So I'm putting them in parentheses to indicate first, because that's a grouping symbol. Then multiply by 10, and it equals 100. We are now going to move on to two-step equations. I would like you to copy these 5 examples into your notes and be sure to leave enough room to solve the problems. You should have a page in your notes titled Two-Step Equations. These are equations that require 2 operations to solve them. Our first example is 4x plus 8 equals 20. In this example, I'm going to try to isolate the variable term first. This means I want to do an operation that will get rid of the plus 8 so I can keep 4x by itself. So I consider what are my operations. This means 4 times x plus 8 equals 20. The inverse of plus 8 is subtract 8. And what I do to one side, I have to do to the other side. So I'm going to subtract 8 from both sides. In doing so, I end up with 4x equals 20 minus 8 is 12. Now I want to try to get the x all by itself. Since 4x means 4 times x, I'm going to use the inverse operation, divide. And I'm going to divide both sides by 4. In doing so, I find that x equals 3. And that is the solution to this equation. In my second example, I have 2x minus 4 equals 12. I'm going to start by getting the x term by itself first. So to undo a minus 4, I'm going to use the inverse operation, add, and I'm going to add 4 to both sides. This gives me 2x equals 16, because -4 plus 4 cancels out to be 0. I now have 2x equals 16. I only want to know what 1x is, so to undo times, I will divide both sides by 2 and come up with a solution that x is equal to 8. And that's the solution to my equation. If I want to be sure that I've done this correctly, it's always a good idea to go back and plug in your answer to see if it actually works. So in this case, I would say 2 times 8 minus 4 equals 12. If I simplify, sure enough, 16 minus 4 equals 12, or 12 equals 12. So I know that I have done this problem correctly because my answer checks. In example 3, we have 2x plus 5 equals 13. So in this example, 2 is being multiplied by x, then I'm adding 5, and it equals 13. To get the 2x term by itself, I will subtract 5 from both sides. I choose subtraction because I want the inverse of this operation, add. So when I do that, I'm going to end up with 2x is equal to 13 minus 5 is 8. To undo 2 times x, I use the inverse of multiply, which is divide, and I get the solution that x is equal to 4. And if I were to go back and plug that in, I would get 2 times 4 is 8, plus 5 equals 13. And it checks. Take a moment to be sure that you have all of these examples copied into your notes, and we're going to move on to example number 4. In example number 4, we have parentheses in our equation, so we have to be very careful about how we treat this. The grouping symbol of parentheses means that if I were solving this and I knew what x was, I would be doing this first. So it means that I want to keep the 3 plus x together as long as possible. This is the example of 1/2 of the sum of 3 plus x is equal to 4. You may recall this from our example on translating sentences to equations. So in order to solve this, I'm going to have to start by trying to undo the operation of multiply out here. I have 1/2 times the sum. I want to keep that sum together for now. So if I have a half and I want to get rid of a half, I could multiply both sides by 2. Some of you would like to think of this as multiplying by 2 over 1, because 2 times a half cancels out to be 1, and I would be left with 3 plus x equals 4 times 2, which is 8. So I now have 3 plus x equals 8. To get x by itself, I'm going to subtract 3, because this is a positive 3. I have to do that on both sides, and my final answer is x equals 8 minus 3 is 5, and that would be the solution to my equation. Example number 5 also uses parentheses. This is also from our translating sentences to equations example. This means that I have 10 times the sum of x plus 9 is equal to 100. In order to solve this, I need to keep the x plus 9 together because they're in parentheses, and I need to get rid of this 10 times first. So if I have 10 times a number and I want to get rid of it, I can use the inverse of times, which is divide by 10. Because 10 divided by 10 is 1. That gives me, on the left side, x plus 9, and on the right side, I have 100 divided by 10 is 10. Now I simply need to isolate the x by getting rid of plus 9. The inverse of add 9 is subtract 9, so I have to do that to both sides, and I get the solution that x is equal to 10 minus 9 is 1. If I were to go back and plug this in to my original equation to check my work, I would find that in checking I get 10 times 1 for x plus 9 equals 100. This gives me 10 times 10, which sure enough gives me 100 equals 100. So I know that I have not made a mistake. We are now going to move on to inequalities. We've not talked about these yet this year, but I'm sure that you have encountered them in the past. Inequalities are mathematical sentences that are not equations. They are actually different. They are sentences that state that something is either greater than or less than. We use the symbols greater than for more than and less than. Sometimes we have a situation in which something is greater than or equal, so we use the greater than symbol combined with half an equal sign to show that it could be equal. Or we have less than an equal, which is less than and half of the equal sign to show that it could be equal. These are common expressions that are used to mean greater than or equal, less than, and less than or equal. Copy these into your note pages. We're now going to talk about translating inequalities. This is sometimes a challenge for students, so we like to get an early start on this in the year. In our first example, we have the sentence, the rent is no less than $400 per month. Remember, if it means no less than, it could be equal or it could be more. So we'll have R for rent is greater than or equal to 400. In our second example, the price of the CD does not exceed $9.95. When we say it does not exceed, it means it can't be more than that. So our price, P, would be less than or equal to $9.95. In our third example, tonight's homework will take no more than 20 minutes. We say that M for minutes is less than or equal to 20. This means that the number of minutes could be equal to 20 or it could be less than 20, and that matches no more than. In our next example, we have 3 less than a number is greater than 12. So this looks like a number x minus 3 is greater than 12. Again, here's our less than expression here, and this one actually refers to subtraction. So that's why we have 3 less than a number, x minus 3. So be very careful not to use the less than symbol here. The symbol that we're using to set up our inequality is based on is greater than, which is in the latter part of the sentence. In our last example, we have 2 times a number, so that would be 2x, in addition to 7 plus 7 is a minimum of. That means that it could be equal to 35 or it could be greater than 35. So we have 2x plus 7 is greater than or equal to 35. Solving inequalities. When you solve an inequality, you solve it exactly like you solve an equation, except if you multiply or divide by a negative number, you must reverse the direction of the inequality symbol. We're now going to do some examples using your notes. So you want to copy these 4 examples into your notebook. At this point in your notes for inequalities, you should have a page of notes that lists the commonly used phrases for greater than or equal, less than, and less than or equal. So you should have all of these phrases copied into your notes. You should also have the 5 examples that we just did translating inequalities. If you've not yet written these down, take a moment to pause the video and write these 5 examples. Our last section of notes is on solving inequalities, and you should have up here the directions for solving an inequality, and we're now going to do 4 examples. In our first example, we have 4x is greater than 20. Since I have 4 times x, I'm going to solve this just like an equation. If I wanted to get the x all by itself, the inverse of 4 times is divide, because the inverse of multiply is divide. So I would divide both sides by 4, and I would have x on this side. I'd have 20 divided by 4 on this side, which is 5, and I'm going to keep the inequality symbol just as it is, because I have not multiplied or divided by a negative number. So my solution in this case is that x is greater than 5. That means x can be 6, it can be 7, it can be 1,000,000, it can be any number that's larger than 5, but not including 5. In my second example, I'm starting with negative 2x is less than or equal to 40. Negative 2x means negative 2 times x. Therefore, the inverse of times is again divide. But in this case, I'm trying to solve for positive x. So that means I'm going to divide both sides by negative 2. Because negative 2 divided by negative 2 is 1. It cancels out, and I would be left with just x. So therefore, I'm keeping that negative symbol with the number I'm dividing by. So on this side, I have x. Over here, I have 40 divided by negative 2, which is negative 20. Before you write the symbol, you should always check with yourself and ask the question, did I multiply or divide by a negative number? And in this case, yes, I did. So I'm going to reverse the symbol. Instead of using less than or equal, it's now going to become greater than or equal. It's very important to remember to do that in order to get the correct answer. This is reversed because this was negative. In example number 3, we have 2x plus 1 is greater than or equal to 5. This is a two-step inequality. We're going to treat it just like a two-step equation. To get the x term by itself, I want to get rid of plus 1. The inverse of add is subtract, so I subtract a 1 from both sides. In doing so, I am left with 2x is greater than or equal to 4. I now have 2 times x. The inverse of multiply is divide. So I divide both sides by 2, and my final answer is x is greater than or less than 2. Remember to always ask yourself, at any point, did I multiply or divide by a negative number? And I did not. I divided by a positive 2. I subtracted. I used a negative 1 up here, but that was not multiply or divide, so that does not have any impact on my symbol. In our fourth example, I have x divided by negative 3 minus 6 is less than 2. Again, I want to get the x term by itself first, so the inverse of subtract 6 is to add 6 to both sides. In doing so, I'm going to have x divided by negative 3. Negative 6 plus 6 cancels, and I'm left with less than 2 plus 6 is 8. Now I have x divided by negative 3. In order to get rid of this negative 3 and isolate the x by itself, I'm going to use the inverse of divide, which is multiply. And since it's a negative 3, I'm going to multiply by a negative 3. So negative 3, and some people like to think of that as negative 3 over 1, cancels with the negative 3 in the denominator. So on the left side, I'm left with x. And on the right side, I have 8 times negative 3, which is negative 24. And again, I need to ask myself, have I multiplied or divided by a negative number? And the answer is yes, I multiplied by negative 3. So I'm going to take this symbol and I'm going to reverse the direction. So that means I now have x is greater than a negative 24. So again, this symbol got reversed because this was a negative number. That's the completion of our notes for today. Thank you for watching this Whybark production.